Alright, today we're going to talk about salts as acids and bases. So we talked about strong acids, strong bases, weak acids, and weak bases. It turns out that salts can be acidic or basic as well. The example we're going to look at for this is KF, potassium fluoride. There's no H pluses, there's no H minuses, so at first glance you wouldn't assume this is an acid or a base. Well, when this dissolves in water, it basically breaks apart into the two ions, K plus and F minus. K plus is supersoluble and stable and does basically nothing. It's not an acid or a base, so we're going to ignore it. But F minus can basically be visualized as the conjugate base of HF, which is a weak acid. So, basically when you write the equation out, if we had HF, which is not what we're starting with, this would fall apart and you get the H plus, which is why it's an acid, because it's a weak acid. But this acts as a base, which is why this is a reversible reaction. Okay, so instead of visualizing, oh, this is a weak acid and we get this, we're literally starting with this. So, if we had a solution of this, of KF, we could basically treat it as a weak base problem. Okay, so you could basically start with the F minus part, reacting with water, and this is going to be our weak base. It was our conjugate base from before. And because this is a base, it's going to steal an H plus, and you form HF, which makes sense because it was a conjugate of this, so it's still the conjugate down here. And then because this is a base, we're going to end up with OH minus. The fact that it can rip off an H plus and form OH minus is why this is a weak base. So, it's a weird thought process, but it's not drastically different than what we've been doing before. Essentially, if you see this, potassium doesn't do anything. It's super stable. It's happy to float around. This is why, like when we talk about KOH, it's a strong base. It's because the OH acts as a base, but the K just floats off and does nothing. Floats off and does nothing here too. The F minus is in fact a weak base because we can visualize it as like starting with the conjugate base of a weak acid. So when you throw it in as a weak base, throw it in water, it's going to act as a base, steal a proton, you form HF, and you get OH minus, and the OH minus is what makes this thing a base.